So let's talk about something that sits at the very heart of science, what we might call the experimenter's dilemma. You see, designing any experiment is this high-stakes balancing act between that incredible drive for discovery and the heavy weight of responsibility.
And that brings me to a kind of provocative question. Can a good experiment, one that's perfectly designed and powerful enough to actually find something real, can it actually be a bad thing? You might think no way, but as we're about to see, the answer is a complicated and increasingly important yes.
The stakes for getting an experiment right are just incredibly high, especially when we're talking about biomedical research. A poorly designed study isn't just a waste of time or money. It can have some really serious, real-world ethical consequences.
Okay, so imagine you're a researcher using animal subjects. You are immediately stuck between a rock and a hard place. If you use too few animals, your experiment lacks what's called statistical power. That means you can't really draw a reliable conclusion. And tragically, the animal's sacrifice was for nothing. But if you use too many, you're causing unjustified suffering and just wasting precious resources. Neither of those is an acceptable outcome.
So researchers have this Goldilocks problem, right? They need a sample size that's not too big, not too small, but just right. And thankfully, this isn't guesswork. There's actually a pretty neat technical solution to find that perfect number.
And that solution really comes down to one key idea: statistical power. So what is it? Well, in simple terms, it's the probability that your experiment will actually find an effect if there's a real effect there to be found. Think of it like the sensitivity knob on your scientific instrument. You want it turned up high enough to detect a signal, but not so high that it's wasteful.
And like I said, this isn't just a hunch. Researchers have these amazing tools, like this free software called G-Power, to run what's called a power analysis. What's so cool about this is that it lets them calculate the exact number of subjects they'll need before a single animal is even involved. It's all about striking that perfect balance between ethical considerations and scientific rigor.
Okay, take a look at these. These are power curves, and they show you that trade-off in action. See here on the bottom, that's your sample size, and on the side, that's the statistical power. As you add more subjects, your power goes up, right? But look what happens. You pretty quickly hit a point where adding more and more subjects barely nudges the needle on your power. That's the point of diminishing returns. The goal is to find that sweet spot, right there on the elbow of the curve.
So all this math is precision. It's not just about doing good science. It's really about doing good ethics. This whole idea of power analysis directly serves the 3 R's of animal research. You want to replace animals with other methods whenever possible, you want to refine your experiments to minimize suffering, and here's where the power analysis comes in, you want to reduce the number of animals to the absolute minimum necessary to get a conclusive result.
All right, so in the super-controlled world of the lab, we've developed these incredible tools to balance discovery and responsibility. But this is where our story takes a huge turn. What happens when you step out of that clean, predictable lab and into, well, reality? I mean, think about it. Take this research on spinal cord injuries in rats. In the lab, everything is controlled. The environment is sterile, you know the animal's genetics, the injury is administered with incredible precision. You can control basically everything. But what happens when your subjects aren't rats in a cage anymore? What happens when they're people, living their lives out in society? What happens when the lab is the messy, chaotic, unpredictable real world?
And that shift, well, it brings a whole new world of problems. As social scientists have packed up their bags and moved from the lab into the field, they've stumbled into a new and way more complicated ethical minefield.
And this isn't some tiny little trend, by the way. If you look at the data from top political science journals, you see this massive shift. For decades, the 80s, the 90s, it was all lab work. But then in the 2000s, you see field experiments start to creep in. And then, bam, in the 2010s, they just explode. Studies conducted out in the wild have absolutely skyrocketed. And these experiments are happening all over the globe. That means researchers are now working in totally new contexts, where a simple experimental design can suddenly crash into these unexpected cultural, religious, or even security risks that they would never even think about back in a university lab. Let me give you a pretty jarring, real-world example of just how messy this can get. In one study, the lead researchers, they're called PIs, actually paid people to commit traffic violations right in front of police officers. Why? They wanted to see if the officers would solicit bribes differently based on the driver's apparent social class. Okay, let's just break this down, because this experiment is, wow, It's an ethical nightmare. First, the subjects, the police officers, had no clue they were in a study and never consented. Innocent bystanders were put at risk. The treatment was literally a crime, designed to provoke another crime. And all of this was funded by a U.S. university to be carried out in a foreign country.
And the complexity doesn't stop there. Here's another challenge. Think about field experiments designed to get out the vote. They sound harmless, right? But what if the intervention is so large that it could potentially alter the outcome of a real election, affecting millions of citizens who never consented to be part of any study?
So you see where this is going. It all circles back to our central theme, the growing responsibility that comes with growing scientific power.
It turns out that context is absolutely everything. An experiment that is perfectly safe in one country can be dangerous in another. An economic game involving chance could be seen as gambling, violating religious rules. A small cash payment could spark violence in a poor community. In some places, even asking political questions can put people in real danger.
Now, having these conversations can be difficult. A common reaction from researchers who feel their work is being threatened is, hey, don't shut us down. They're worried that too much scrutiny will stifle important discoveries.
But the counter-argument is powerful. Unconstrained ambition will shut us down. The biggest threat to future research isn't a careful ethical review. It's the risk that a single major scandal could cause governments to cut off funding or deny access to entire countries for all researchers. Which leaves us with this final thought. The tools of science, from power analysis in the lab to large-scale experiments in society, are becoming more powerful every day. The dilemma we face is ensuring that as our ability to find answers grows, so too does our wisdom in asking the questions. The solution isn't to stop experimenting, but to become more thoughtful, more context-aware, and more responsible in our quest for knowledge.